Hey guys, this is Miss Holtz, and in this video I'm going to be talking a little bit about how to break down a vector. So a lot of the motion we've been talking about has been one-dimensional motion, things moving in straight lines. But we're going to be moving on to objects that move in two dimensions, things being thrown through the air, that sort of thing. So we need to be able to break down vectors. So we know that vectors have a direction and a magnitude, and when you're talking about the arrows that you draw, those kind of vectors, the direction is which way the arrow is pointing. In other words, its angle. And the magnitude we can see is how long the vector is, or its length. So let's look at a scenario. So let's say we have a guy going down a water slide into a pool of water, and as soon as he leaves that slide, he has a velocity going upwards and to the right. This arrow right here is his velocity vector. And we want to be able to describe this vector in terms of its direction and its magnitude. So let's start with direction. So the direction is the angle, and the angle is measured counterclockwise from the positive x-axis. Okay, so I put our vector on an x and y axis, coordinate plane. So this is our x, and this is our y. And this is our negative x, and this is our negative y. So this is saying it's measured from the positive x-axis. That would be the vector, the angle of the vector is between this axis and the vector. So we're looking for this angle right here. And we call this angle theta. That's the Greek letter theta. So let's put a little compass on here. And we have all of these different angles marked out. So this here would be 0 degrees. This is a 90-degree angle right here. That's 90 degrees. This is 180 degrees. This is 270 degrees. And this circle happens to have markings marked out every 15 degrees. So this is 15. This then would be 30 degrees. So measuring our angle of our vector, we know that the direction of our vector, or theta, is 30 degrees. And if we had any other sort of vector, let's say we had a vector down here, pointing straight down. Sorry if that's hard to see, but it's pointing straight down. So the angle of this vector would be 270 degrees because its angle from the positive x-axis is 270 degrees. Okay, so we found the direction of our velocity vector. Now we're going to find the length of the vector, or its magnitude. So I'm gonna try to figure this out. And the reason why I have this grid here is because we can use the squares to find length. But this is at a diagonal, so we can't really just measure how many squares it is. We can't count the squares. So we're going to have to build a triangle and use the Pythagorean theorem to find its length. So I'm going to build this triangle here just like this. And now we can count the number of boxes of this arrow and the number of boxes that that arrow is. So this arrow down here is 1, 2, 3, 4, 5, 6, 7. And let's say this is miles per hour. And this one is 1, 2, 3, 4 miles per hour. So we can use those two arrows to determine the length of this arrow. And if you remember Pythagorean's theorem, it's a squared plus b squared equals c squared. So let's call this our a. This is our b right here. And our velocity is our c, the c side of our triangle. So if we're trying to find c, we need to take the square root of everything. So now we have the square root of a squared plus b squared equals c. And now we can plug in numbers. So the square root of 7 miles per hour squared plus 4 miles per hour squared by the way, that's all under a square root, equals c. So what is 7 squared? That would be 49. 49 miles squared per hour squared plus 16, which is 4 squared, miles squared per hour squared. Those are kind of funky units, but they'll work out here in a second. And so when I put that in my calculator, I get 8.06 miles per hour. And that equals c, which is our velocity. So we just found the magnitude of our vector using Pythagorean theorem. Another interesting thing about vectors is that they have components. And the definition of a component is that it describes the effect of a vector in a given direction. So let's take a look at that. Here's our vector again, and I put it on a coordinate plane. Since a component describes the effect of the vector in a certain direction, let's describe this vector in the x direction. And to do that, we draw an arrow on the x-axis that represents this vector. This vector has a component in the x direction. It also has a component in the y direction, which we use these components to find our magnitude when we use Pythagorean theorem. So this component right here is the y component. You could also draw it on the y-axis, but I often like to see my vector components in a triangle. It doesn't matter where the vectors are, right, because we can move vectors around. But let's draw it this way for now. And let's label these vectors. So this vector down here is the x component of the velocity. And this vector along the y-axis is the y component of the velocity. And this will come in handy a lot when we're working with two-dimensional motion, especially when we have a scenario with someone flying through the air off of a water slide or anything else that has to do with two-dimensional motion.